Hello guys, welcome to episode 4 of how to make a multiplayer survival arena game using Unity's Unet system. Just a quick thing, I do apologize for the delay from my last video, but I have been busy with celebrating Christmas with my family and also been working on a sick new inventory crafting system that I hope you guys will enjoy. So with that said, let's get started. Today we'll be working on giving the player the ability to shoot stuff essentially, and in the next video we'll introduce different types of guns, so that includes firing rate, reload speeds, etc. But before we get going with that, we're gonna have to do some housekeeping. At the moment, when we start the game, we are able to control every player in the scene, though we only want the player to control their own character, as you should. So to do this, we go ahead and go to our scripts folder and create a script, C# script, and call this one player setup. You can call whatever, but this is the script we're going to use to set up our player when we get spawned in the scene. So yeah, essentially the script will check if we're the local player, and if we aren't, then we want to disable a bunch of stuff. So you can go ahead and open it up, and first thing we're going to have to do is we're going to say we're going to want to use Unity Engine's networking. So what this will allow us to do is we'll be able to inherit from the Unity Engine networking's network behavior in our script. So we're going to be if you're unfamiliar with namespaces, they're essentially just a scope that contains a set of related objects. So you can have, as you can see here, we're using Unity Engine's mono behavior. So the class is deriving from Unity Engine's mono behavior. So you can essentially just say, let's take this out and go, and there it is. But we just declare it up top, so it's just easier for us to see what we're using in our scripts. So here you see it's highlighted because we are using it, and these two currently aren't being highlighted because we aren't using it anywhere in our script. So for this, we can just keep it how it is, but here we're going to take away the mono behavior, and we're going to be using Unity Engine networking network behavior. So whoa, that's a mouthful. So we're going to take this away and go network behavior. If we see how it highlights it now, and Unity Engine is gone, is unhighlighted, is because we are now using this in our script. And the network behavior just gives us a list of rules, more rules and stuff that we can use within our script that it can easily identify. So basically the script is just a list of components we don't want running on other game objects, and we put it into a list or an array, and when the game starts or the object spawns in the scene, then we're going to check if the player is indeed the local player, and if it's not, then we go ahead and disable a bunch of stuff. So we go ahead here, and when we start the scene, we can take away this. We don't need that in our script, and we say if is local player, and the local player is just a boolean that is a set function or rule within network behavior, and we want to check if we're not. So if you don't want to, you want to say the false of it, you don't want to say it's true. So essentially putting a exclamation point before it means you want to check if it's false. So essentially all it is saying if false. That's all it's. You're just taking away that and putting that there. Just a little handy tip. So if we're not the local player, we want to go ahead and disable a bunch of stuff. So up here, we want to say what we want to disable. So we're going to want to get different scripts. So to do that, we're going to have to look at behaviors. So behavior is just a component of what you can enable and disable, as you can read there. It's pretty self-explanatory. That's why I don't need to go much in depth through it. It explains itself. So once you get that, we can go ahead and call this components that are components to disable that we want to disable. Components to disable. So here we go ahead and go through a simple for loop. If you don't know what a for loop is, I'll be explaining it in my C# tutorials later on in the year or month even. So we just go through a for loop, and you can see I didn't type it out. All I did was type out for and double space tab, and it prints out a generic for loop. So int I equals 0, I is less than length I++, but we want to, instead of length, we want to go through the components to disable dot length. Oops. And I just realized we want to have an array. We don't just want a singular one, we want the whole array. So now we can get the length. And once we do that, we can just say components.I, the one that we're on currently, and we want to say enabled equals false. So essentially it's just saying disable it because we don't want it to be enabled. So after we did that, we can go ahead and go to our character and go ahead and oops and drag on, we'll just look for it here, player setup, add it to our scene, and we're gonna have to be able to see it. So here you can make it public, but there's no need. We can just say serializable field. Yeah, serializable field instead of public sounds a lot better, and we'll go ahead and be using Unity Engine for this. Take away that neat little script, and now we just go back to our scene, and oh, thanks Windows 10 viewers. Alright, sorry about that. Go to our scripts, and for now I think we only need let's say 7, just for safety. So for the basic ones, we went ahead and character movement, body rotation, and I want to drag. And so see, I'm going to click here, and it's going to change the inspector. To stop that from happening, you go ahead and press the lock button. It just locks it on the screen. You probably see my setup here. So I have 2 project files and 2 inspector things because of this debacle. So this is now locked in there, and we can go ahead and go to our head here, and you'll come up in this second inspector because it's not locked. And we go ahead and drag this over here, and we'll just keep that locked for now because we want to add the camera components that we want to disable. And we want to disable the camera, camera, and audio listener, big one there. There's no need to disable these. So we have 2 extra ones. We can just go ahead and say 5 that we want to disable. and hit apply and delete it from our scene. And we can go ahead and test it here now. And we go to play here and spawn in. So as you can see, I am currently not controlling the other player. So if you go back here, oops. So here, the other player's not moving like we did before. So just a little housekeeping today. Now we can move on to the proper topic. So we can go ahead back to our script folder and create another C# script, and we're just going to call this one, I want to call this shooting. It's pretty basic. You can call it whatever you want to keep track of it. It's just, I want to keep track of what's happening from the script. So go ahead and open it. And again, we're going to be deriving from network or Unity engine networking. And just like before, instead of mono behavior, we want to derive from network behavior, because we're going to be using the commands, functions, the sync var functions, and etc. So once we've done this, I'm going to take a moment to say today we're just going to be working on a basic functional shooting script. I'm going to go in depth and make this advanced later on in the series, but today I just want to have the basic shooting so you guys can see what's happening. And it's pretty easy. This is the hard stuff, and you guys can customize whatever you want at home. I just want to give you the essentials in understanding what to do here. With this said, we can go ahead and go to our update function and check 60 times a second whether or not we are pressing down our left mouse button. What I mean by this is the update function is called once per frame, and there are, depending on other variables, 60 frames per second. This is a built-in Unity function, so it is called 60 times per second. So we're going to be using get mouse button instead of get mouse button down, because I don't want the player to have to manually press down every time they want to fire a bullet. What I mean by this is, so we're going to say if, our input, so it's a input that we want to look for, and we're going to say get mouse button, that one. So for down, it is only called when we press the specific mouse button down, and up is just when it's called when you let go of that button. So, but instead we're going to be just calling the get mouse button. So all it's doing is checking whether or not it is down or not. That's all it cares about. If it's up or down, it doesn't matter. It's if it's down currently. And we're going to want to check the left mouse button. So for this, its identifier is 0. For the mouse buttons, it is 0 for the left mouse button, 1 for the right mouse button, and 2 for the scroll wheel being pressed in. So if we're pressing down the left mouse button, then all we're doing is calling a function. So for today's script, that's all we're doing. So we're going to say fire. So easy peasy. And once we do that, we want to say for this function, so let's get the function out. So for this function, we want to only call it on the client. So the nothing needs to be done on the server. All we're saying is this exact thing will only be called on the client. So this is a attribute that comes from the network behavior. So for this type of shooting, we're going to be using raycasts to shoot instead of prefab shooting, which we're probably going to add later with spear throwing and bow shooting, etc. But for most gunfire, you essentially are going to rely on raycasting because it's more efficient, more reliable, and it's easier to use and to understand and stuff. But we're going to be using prefab shooting. So what I mean by prefab shooting is we're actually spawning an object into the scene with proper physics and little cute stuff, mainly just physics. So when raycasting, it casts a ray from a point origin in a direction for a certain length against all colliders in the scene. So what I mean by this, I don't mean all colliders in the scene. It is the only one that is intersected with it. So the physics raycasting is just a boolean. It checks whether or not the ray we just shot intersected with anything that has a collider on it. The function we're going to be using requires a point of origin, which is a vector 3 in the world space. So it's just the exact point or location in our 3D world. Now, once we have the point of origin, then we're going to tell it what direction we want the raycast to go. For direction, you can cast a ray in whatever direction you choose, but in this case, because we're shooting a gun, we want the raycast to go in a forward direction of what the gun is facing. At this point, we can limit the length of the ray that we just shot. You can make it infinity, as I said, but in this case of guns and such, it isn't very realistic for a pistol to be shot and hit a target from a 6-kilometer range. So we're just going to limit it in our case. The raycast hit here is the info of the point and direction of the raycast that we just intersected, and it also gives us the game objects that we just hit information. So what I mean by this is, so let's just say we hit this object and it has a collider on it. The raycast info will be the object's name and just everything that the object itself has. So every class that Unity gives us that a game object would have, it gives us that information, and we can treat it like any other game object, and we can get other information from other scripts from that. And I know it sounds confusing from this diagram because raycasting is a semi-complex thing, but this is the direction of raycasting we're going to be using. So we're going to say, we'll just say if, so it's a boolean, so physics dot raycast, and we're going to say, yeah, we'll just keep it from later on. We're going to say what position we want it from. So we're going to say from the barrel end, but we don't have. Actually, we can go ahead and say the barrel length. So we're going to say up here. We're going to go transform. Oops. Transform. Gun barrel. Or we'll just say barrel. And we're going to say barrel dot dot. You don't need to get the position. Good. It is already a transform, and we're going to say transform dot forward, because that is the direction that we want to shoot it from. So direction of the forward. The forward, it sounds weird. And we want to get out the info. We want to be able to store it somewhere. So for this, you can generally store it in here as a local variable, but I'm going ahead and put it up here. So what we put up here is the raycast hit variable. It is a built-in variable in the Unity engine namespace. So, and we just call this hit. Easy. So for this, we're going to say we want to send out the information to the variable hit, and we're just going to say the length of it will be 100 units. And once that's it, and we can go ahead and test it if it's working. So if it hits something, then we want to say debug.log hit.transform. Names is easiest because we'll be able to see what we're actually hitting. So go ahead and add that to our game object. Let's just drag it into the scene here, and add that to our character. Let's just minimize this so you can see it. And oops, for now we just keep this a public variable so we can see it here. And we're gonna add, and I just realized we don't have a gun, so let me go ahead and build one really quick. It'll take a second on your screen, but we'll be right back with a gun. So welcome back, and as you can see, I now have a gun in my scene. It's just two cube objects that I just manipulated into a gun-ish shape. Later on, we're going to add our own guns. You can always add your own model of guns. You can import it from the asset store. They're really cool. I'm going to make my own later on, but for now, this will do. So in our gun object, we go ahead and create an empty game object and drag that to the front of the gun. So not touching, but just in front of it. And we'll just call this barrel. And it doesn't matter. Apply that, and we drag over the barrel and transform, and we can go ahead and apply, delete, play, and shoot things. And go ahead and go to our console here, and you can see different things that we're shooting. So we're getting feedback of it working. So once we did that, we can go ahead and create a test dummy that we can shoot at. So go down here, create another C script, and just call this test dummy. Oops. Why does this keep coming up? This is so annoying. And we go ahead, get rid of these. They're not. We're just going to create our own methods, and we're going to say void take damage. That's all it's going to do. That's all its purpose. It takes damage. So, and for now, we're going to leave this without parameters. We just want to keep a debug.log statement and say, ouch, I've been hit. And we go back to our shooting script, and if we hit our hit dot collider dot tag is equal to test dummy. Generally tags I've heard very inefficient, but in most cases it's just the simplest way to check something. It doesn't really matter to me the I don't know, that quote unquote FPS of the game, but I just wanted to have a functional game really, so we'll just keep tags in it. So if we do hit it, then we're going to go ahead and call a command function. So this new function is going to be a command, just like the client derivative. It comes from the network behavior. So the command here means we're going to send let's go over here. So once we're going to send a message to the server that a function should be called on a client. So in this case, we're going to say void dot this one's going to be void cmd, capital CMD. Every one of the anything that is derived from the command function needs to have the CMD prefix, and we just go to underscore and call this shoot thing. You can call it whatever you want. I just want to keep it simple for the viewers. So right now we're going to feed in two parameters, game object, and we'll say object, and int, which is going to be the damage. So right now we're not going to be applying damage to our test dummy. We will in a sec, but we're just going to have this now so we don't have to come back later. So first we want to get the object, and we want to get the component test dummy, and we're going to call the function, we're going to have a public accessor on this one, so we can call it from this script, and we're going to say, there it is, take damage. And easy as that, we can go ahead and create a little cube, pretty big cube, and drag over the test dummy script, clear this, and we go ahead, I just forgot, we didn't actually call this anywhere, so we go up here, command, and we're going to feed in the hit dot transform dot game object. So our hit information, we're going to feed in, we want to get the game object, the complete game object, and we're just going to say 1. Doesn't matter what we put now because we're not accounting for the damage, but we'll just say 1. So go to our script, go to our scene, press play, post. We're not going to be able to hit anything. We're going to have to add a new tag. So to do that, go under tags and go add tag, and go ahead and, so we don't make a mistake here, so test dummy, copy, paste, and I always forget to do the next step. You have to go back to the game object and add it. And once it's been added, we go ahead and press play, and it should be working. Go ahead and press play, and as you can see in the console, ouch, I've been hit, is being logged in the console. So you can see everything is working. In the next video, we'll be looking at having multiple kinds of weapons. So when we come back to our shooting script, it might be in maybe a week. I'm hoping to get the inventory crafting system recorded and uploaded onto YouTube within the week, but we'll be adding onto the script, the shooting script, adding our own gun systems, having different types of guns, reloading, you name it, I'll have it. Just comment in below what you want to see in the gun script. Thank you. Goodbye.